Hi guys, I just wanted to go over really quickly some things that I wanted you to label on your periodic table. I'm not positive if every class got this labeled on their periodic table or not, so just to be safe, I wanted to make this video just so that way you had it and we could label them together just very quickly. So on your periodic table, I wanted you to label at the top 8 columns for me. If you would label for me the hydrogen family and the alkali metals. So if you would label that whole column for me as 1A. The column right next to it, which is the alkaline earth metals, if you would label those 2A, move over to the boron family and label that 3A. The carbon family, label that 4A. The nitrogen family, label 5A. Oxygen family, 6A. Fluorine family, 7A, or halogen family, 7A, and then the noble gases, label that 8A. What this A represents is it's a way that chemists can say that these are called representative elements. So all of those columns that are designated with an A, we call A elements representative elements. A representative element is an element or a group of elements that have very, very different properties. And you already know that. You know, when you look at 1A, which are the alkali metals, super reactive with water, the most reactive metals, are totally different or have different properties than this group 8A, which are the noble gases. Unreactive, have full shells. They don't even want to have a charge. So when we say representative or you look at the A elements, just know that their properties differ dramatically. Now, on your periodic table, the transition metals, as well as your lanthanides and actinides, we call those B elements. So this whole group of transition metals, just like these two rare earth metals, or rare earth elements, those we call B elements. And B elements just represent elements that have similar properties. So they're all metals, they can have multiple charges, and another thing that we can say about them is that they typically give off really bright, beautiful colors. That's really another common property of all of them. So they act very similarly. So B elements act very similar. They have similar properties. And then A elements, we call those representative elements, and their properties differ. Their characteristics differ dramatically. So the A elements are the 8 columns that you just labeled for me. Now underneath those 8 columns, I want you to write some charges down for me. So underneath your alkali metals, if you would write down for me a +1 charge. So underneath the alkali metals, write down a +1. So why are we writing down a +1? We had talked about this in class on Monday, that we know that the alkali metals and hydrogen have 1 valence electron. Because they have 1 valence electron, it's easier for them to get rid of that 1 electron than it is to gain 7 more. So it wants to get rid of the 1 electron. If it gets rid of 1 electron, it's going to end up having 1 more proton than electron, which gives it a +1 charge. The group right next to it, the alkaline earth metals, that's a +2 charge. So I want you to write that on your periodic table for me as well. You know it's a +2 because there's 2 valence electrons around that outer ring, and it's easier for one of those metals to give away 2 electrons than it is to gain 6 more electrons. So because it gives away 2, it ends up having 2 more protons than electrons, so it has a +2 charge. Now if you'll go over to boron family, I want you to write a +3, and understand that they have 3 valence electrons, easier to get rid of 3 than to gain 5 for an outer shell. If we look at the carbon family, this is one of the only exceptions for our plus or minus charge. So if I look at the carbon family and go down, I know that carbon has 4 valence electrons. It's the same amount of energy to give away those 4 electrons as it is to gain those 4 electrons. So because I can see it as gaining 4 or losing 4, that means that this column could have a +4 charge or a -4 charge. So it can act in either way. So underneath that column, would like you to write a +or -4. Okay, the nitrogen family let's go next to that group. Nitrogen family, we know nitrogen has 5 valence electrons in its outer shell, and we know that if I was thinking about nitrogen, it would want 8, a full shell, but is it easier to get rid of 5 or gain 3 more to get a full shell? In this case, it's easier to gain 3 electrons, so since it's adding 3 more negative charges, that's why we give that the -3. Next one, which would be your oxygen family, we'll give that a -2 because it has 6 valence electrons. It needs 2 more electrons to be stable. Easier to gain 2 than lose 6. You know your halogen family is a -1 charge, and your noble gases are neutral. They don't have a charge because they are unreactive or they are inert. Guys, I also just want to tell you very quickly that I think you did a really fantastic job asking questions about all of these quantum mechanical model notes that we've been taking in class. So I'm really proud of you guys, and you're working really hard. Tomorrow we're going to finish up our lab, and then we will also start working a little bit more on electron configurations, which is something new, and that way we can play Electron Configuration Battleship on Monday or Tuesday of next week. Have a good night, guys. Bye.